Hi, everyone. Welcome to the first Q&A session for Video at Scale. Thank you, Mike, Zainab, Mohanish, and Jithin for your talks. I think even though I worked at Video Info with you guys for a long time, there were a lot of things that I didn't realize, I didn't know until I listened to those talks. So thank you for them. Let's jump into the first questions that we see now. The first question is for Jithin and Mohanish, whoever wants to pick it up. The first question is, different apps could have different requirements on Dash or HLS manifest. For example, one app or use case may only want higher or lower renditions. Do we generate them beforehand or on demand? Or do we use a shared Dash or HLS manifest but rely on the players to decide?
Thank you, Tia. I can take that question. Firstly, that's a great question to start the discussion. Short answer, no, we do not generate every manifest beforehand because for the reason you mentioned, things change. Every app, every product, like every app like Instagram, Facebook, every product within that has different requirements which dynamically change. So on the back end, we have a dynamic manifest generation service. What the service ensures is based on the real-time requirement that the app or the player is telling us. We in real time will put together all the different permutation combinations which suit the best for the current user who is trying to watch the video and stitch together the manifest and deliver it to the user.
Got it. Thank you. The next question is for Mike. So how long does it take for us to compute the move atom for a large video?
Thanks, Tia. Yeah, it's a great question. So the video duration is actually the biggest factor for how long it takes to demux a video, as opposed to the video size. If you have a high bitrate video that's 10 gigabytes, but it's only 30 seconds long, then the actual metadata about the video is fairly sparse throughout the video, and then the video data is like the large portion of the size. If you take over like a 4-hour live video where every 5 seconds you have a move atom, those are the ones that are actually like hard to demux because you have to do a bunch of really small reads across the entire file. And so those are the ones that actually take the longest, and that might still finish within like a second though, because you basically are fetching a very small portion of a lot of different byte ranges of the file. So yeah, the long answer short is that we can do pretty much every video in like less than a second.
Okay, that's good to know. The next question, or I guess it's a statement during Mike's talk, but I wonder if you have any comments on it. The statement is, FFmpeg, OpenSSL, and HTTP Connect already handles this through byte range calls.
Yeah, no, it's a good observation. So I know I've seen posts where people, to connect to say like Amazon S3, for example, you use S3's CLI to get the HTTPS URL, and then you can use HTTP chunk transfer and range requests to actually like slice into the bytes. However, the pro of FUs still is that we get a lot of lower level control over how FFmpeg's reads, which tend to be like really small byte range reads, maybe only a couple bytes at a time. We can control how those actually map to backend reads against our blob store. So if FFmpeg accesses maybe only 5 or 10 bytes, we can translate to that to the optimal read size for our backend, which might be 8 megabytes. And then we can also do read ahead caching and stuff like that. And then when it comes to streaming, so streaming inputs or outputs to FFmpeg, same thing. You get a little bit more control when you're connecting FFmpeg like directly to the client of your blob store, as opposed to having to like coerce everything to fit into HTTP chunk transfer, be it for upload or download. So we did definitely consider HTTP connector, and it's definitely useful and easy because it works out of the box. But when you really want to have like fine level control, it's nice to be able to directly map any FFmpeg IO operation to how you actually want that translated to the backend.
Got it. Thank you. The next question is for the floor. So whoever wants to take it. The question is, I am curious how you measure the efficiency of infrastructure cost savings because we are running our own data center.
Uh,
I,
yeah, I think probably each one of us can add to this.
Sure.
I can start with it. So yeah, that's a pretty in-depth question. So the short answer is, there isn't one specific metric that measures the efficiency or saving of the entire infrastructure. So on a high level, the team has come up with separate metrics to measure the efficiency and in terms of compute. For example, when you're talking about the delivery stack or encode processing stack, then when it comes to storing the videos, we are looking at storage as a metric. When you're looking at user experience as one of the metrics, then on the right side we're looking at latency. On the viewer side, we are looking at video quality, MOS, and a bunch of other metrics. So in a nutshell, there's a combination of multiple metrics that work in tandem. The end goal is, of course, to give the best user experience. But then for delivering that best user experience, how do we tweak each and every metric to make sure that we are doing this optimally? And if at all we see leaks in any of the metrics, the separation of the current stack or the architecture or the framework of metrics will help us decide what is the aspect that we need to go tune by making sure that the user experience is not regressed. I would stop there. Any other thoughts, please?
Anyone else have anything to add to that?
So for when we talk about efficiency, right, we basically think about compute and storage, right? With compute, we have a finite amount of compute, and the model that like Zainab described is we basically try to do the most we can with whatever the compute is. And as the day goes through, there are like peaks and troughs where we get a lot of uploads, and then at nighttime when people are sleeping, there's less traffic. And so we try to use that off-peak time to like fill in the gaps and improve quality. So that's like the model on compute. And then storage, again, it's like there's the stuff you have to store permanently, and then we try to also make the best encoding possible, like while the video is actively being watched, and then try to clean up when the video is not popular anymore.
Yeah, and to add to what Mohanish mentioned, there's also work going on to see if we could build a uniform normalized metric that could capture all of these different dimensions across compute, storage, and even egress. That's still a work in progress, but yeah, at the moment, it's a collection of different metrics that we monitor to ensure that we are making best use of the resources that we have, and we also don't regress the experience that our users get.
Got it. Yeah, that's a great point, and it's a really good question. I think it's a very complicated issue here, but I guess as Jithin said, it makes sense to simplify it. So the next question that we have is for Zainab. So Zainab, you mentioned expect the unexpected in learnings. So looking at the history of New Year's Eve at Meta, has your team ever been taken by a surprise or observed unexpected behavior during the event? And if so, how did you learn from it?
That's a good question. So the first part of my answer is going to be boring because I think Uma's a new service. We've been around for about 2 years or so. New Year's Eve at Uma has actually been really boring. It's been actually quite silent. And that's because testing has been really exciting. We've kind of front-loaded all the issues that we could have seen on New Year's Eve prior to that. So I can talk about like the more exciting issues that were hit during testing, which meant that we had a boring New Year's Eve. I think one of the really nice benefits of load testing is it is the best way to verify capacity. So did you actually turn up enough capacity to be able to take the load that you're expecting? When you're running a load test, you'll very quickly see that, oh, hey, this service or this region is running really hot. And it gives you a chance to kind of take a step back and redo that whole exercise. Load testing is also a really fun way to find out you have bad configurations. So you might realize that, hey, I drained that region when I was on call last week, and like I forgot to undrain it. That region is completely idle. I'm load testing the service, and like that region's not doing anything. So interesting configuration issues that we'll find. I think another fun one that we find are retry storms. So when you are load testing, you are more likely to hit error paths, so things going wrong. So you have a really nice check on, hey, what are the retry policies on this path? Are we seeing that with every hop, we're multiplying the retries? And is that how it really should be happening? So I think those are like the more exciting things that we found during testing.
Well, it's good that we catch them during testing and not during New Year's Eve. Thank you. There's one more question I see for Mike. So it says virtual file is very similar to QuickTime reference technology. Was that a consideration when you were developing virtual files?
Yeah. So like QuickTime reference and also just like the MP4 spec itself does have a lot of like interesting features built in to support similar ideas. Like you can have an MP4 file where the data is like a reference to some other file. And so in that sense, yes, it's like very similar conceptually. Probably the only real difference between what this is doing and QuickTime's reference files is in the implementation itself, right? Again, because we're really concerned about being able to serve these files in low latency, the main difference is like we want to be able to go from a dash file to having sort of like the equivalent of the QuickTime reference file. And we want to do that without having to download the entire source file. And so ultimately, it's really just about tooling, right? You want to make the tool to go from two dash sources like audio video to having your like reference file or your move atom or your virtual video file, whatever you want to call it. You want to be able to do that with like minimum latency, minimum bytes read, because at the end of the day, we have like a user or someone out there waiting to watch this video, and so it needs to be fast. But yeah, there's a lot of overlap in the tech, and conceptually, they're basically the same thing. Yeah.
Got it. Awesome. Thank you. The next question is for Mohanish. So you were talking about the video shared infrastructure. In this world, how does your team decide how to prioritize traffic across the multitude of apps?
Right. So one of the guiding principles of the shared infrastructure was, as we were trying to solve the problem of defragmentation, moving from a vertical stack model to a horizontal stack model, one of the main guiding principle that we made sure was tenant isolation, which is end-to-end vertical tenant isolation, right? From the moment the request enters the data center all the way down to, if it's processing a video upload or when it comes to delivery. Now, given this inherent capability that we have built, there is prioritization that is happening on two fronts. First is the end app, like for example, Facebook Messenger, they pretty much have control of everything that they drive from the products. This is tweaked through configs, and they control the capacity. The second is diving a bit deeper into capacity is about prioritization within a specific app. For example, Facebook or Messenger or Instagram will have X number of video uploads. Now, amongst these video uploads, again, each of the app have the required controls or the configuration to decide the prioritization. As you saw in the talk already, the view time encoding component that we have, that is something that each app controls in a tenant isolated way. They decide what heuristics that they want to use to essentially prioritize which videos should be processed with what encoding, which videos should be processed over other videos, and things like that. So combining both these models together, end of the day, the app has full control on what gets processed, when it gets processed, and if they want to change it, they can change it based on their needs. And lastly, to conclude, all of this, the capacity tuning from the compute pools down to the storage pools also is completely tunable and owned by each and every app.
I see. Yeah, that sounds like a good way to avoid noisy neighbors. So even like Messenger has to bring their own capacity to prevent them from using Facebook capacity and affecting their traffic.
Exactly. So pretty much Messenger, Facebook, they are all operating as tenants on the shared infrastructure at this point.
Thank you. The next question is for Jithin. So I think I can attest to how challenging it was to actually move to this stack. What were the challenges specifically the team faced in migrating the production traffic to the new infrastructure while ensuring that the user experience was not affected?
Yeah, that's a great question. This whole project took, I think, about 3 years from start to finish. And one of the first challenges we had was looking at the existing infrastructure, all the different pipelines and logic that had been built over several years, and distilling that into APIs and features that were not duplicated and also were extensible and provided a solid foundation to build on top of. So just looking at the existing system and breaking it down into what it would look like in the new world, and that it satisfies our requirements of extensibility and decoupling and so on. That I think was a major challenge. We had multiple rounds of design discussions, brainstorming sessions, and it continued throughout the lifecycle of the project as we tackled every single feature. I would say that of all the stages, probably implementation was the easier one, because once we knew what we needed to build, we just went and built it. The next big challenge was actually migration, because we couldn't just bring down the whole system and then reboot it at some point, right? So we had to keep the system running. Users should not have any regressions in either creator experience or playback experience. And we couldn't regress our the storage and compute efficiency wins that we unlocked over the years. So migrating the whole thing while keeping the system running and validating that every single point is at parity. And this includes upload time, creation, reliability, and latency. It includes playback quality, storage and compute efficiency, and a host of other metrics. So it is almost like you have a bunch of buildings with their own foundations, and you sort of keep the buildings intact, remove all the foundations, and put a new foundation that covers all of these. It is kind of like that. So yeah, just maintaining the whole thing, keeping the lights on, and at the same time shifting this under the hood. That was a massive challenge, and it took a bunch of teams and engineers, everyone over here, to actually get it done successfully. So a lot of interesting learnings and experiences that came out of that exercise.
Yeah, 3 years sounds like a very long time for sure. Like, is that something you guys anticipated when you guys decided to embark on it? Or was it like a lot of unexpected obstacles that made it take 3 years to finish?
I think it was, I don't think we really discussed the 3 year. We had a roadmap somewhere to the midpoint. Like, we knew the next couple of big milestones we wanted to hit. And once we hit those, the subsequent milestones just got unlocked. So I don't think we looked at it as an entire roadmap from the start. Like, we had some vague idea of where we wanted to be, but we just took it like a couple of milestones at a time. And yeah,
I feel like it was the last 20% was the longest and hardest. It always is. It was easy to get most videos moved over, but not everything. And then the last 20% took forever.
You saved the hardest part for last, I guess. Yeah.
There were definitely quite a few surprises.
Okay. Awesome. The next question is for Zainab. So preparation is a big part of New Year's Eve. How does the team go about predicting how much traffic to expect on the big day?
Oh, okay. So there is a lot of data science magic, I think, that goes into it. But I think maybe there's like a few key things I can point out. So obviously it's a very data-oriented decision. We are looking at, number one, how have past New Year's Eves been? So, what kind of spike did we get? What did we actually think we would get? What was the delta, and what are the learnings there? So that's like the first thing. You're establishing your baseline. We are also going to look at regions. So I kind of tried pointing that out in my slides. One of my slides had a graph of like, hey, look at our peaks throughout the day. So you'll notice at different times of the day is a different region, and they all have different spikes. So like North America, like California, PST, like we're not super excited about New Year's Eve. But if you look at like the Eastern Asia, super excited about New Year's Eve. So we'll take that into consideration. We'll take into consideration the regions that are coming in. We are also going to maybe consider world events. Like, do we expect an impact on New Year's Eve? Like, let's think back very recently, we think back to COVID, right? How do we think that's going to impact New Year's Eve? We have to make a call. So how are we going to speculate? And we're going to add buffers everywhere just in case we're wrong.
Got it. Thank you. I think we have 1 more minute left. Maybe I can squeeze in one more question. What is the SLA for the services, and how do you measure SLA and hitting reliability and availability requirement? This question is for the floor.
I don't think I can
Go ahead.
give a quick 20-second. So everyone here basically works on different services, and every service is going to have a different SLA. And even the question of like, what is the SLA and what should the SLA be is such an in-depth conversation with your customers. All of our customers might be similar because we are, I suppose, serving all of Facebook, all of Instagram, etc. But yeah, so there's no one SLA. Every service will have their own thing. An example SLA that I could talk about is in the Lambda service in UMA, I mentioned, hey, we have a scheduler. You know, a very clear SLA that we're going to have on the scheduler is scheduling latency, right? So what is like the P99 latency that we're okay with, that we are promising our customers, especially knowing that we are serving user blocking traffic. Yeah, again, everyone here works and is expert on different services. If you guys want to jump in.
I think another one, like Zainab mentioned, it's all service dependent. Another one that's closer to products is what is the success rate of publishing? So if you have 100 uploads coming in, like how many of them actually go through and successfully have their encodings and thumbnails extracted and published? Another one is upload latency. Then there is, like Mohanish mentioned earlier, like there are the playback quality SLAs, like what's the average quality score that we observe in a certain playback session and so on. Yeah, I think Zainab put it really well. It's very service dependent, and it's not just one single metric. It really depends on the service, and it's the aggregate of all of these metrics that helps us define what the system should be doing at any given point.
Yeah, that makes sense. I think we've hit the end of our Q&A. Thank you guys for taking the time to teach us about video at scale at Meta. And we have a next round of talks and then a next round of Q&A. So I invite everyone to keep leaving questions in the forum. We really enjoy interacting with you guys and answering them. Thank you, everyone, again.